In this episode, I shall continue working out the sums on permutation first, then I shall move to combination. In the last episode, I discussed different restricted permutations. On the basis of that, I shall work out few more sums on restricted permutation. Sum number 1. First, I write down the sum. How many numbers are there between 100 and 1000 such that at least one of their digits is 3 and the other is exactly one of the digit is 3. From the condition, it is clear that the number will be 3 digit each. To solve this sum, first I draw the diagram like this. Units place, tens place, 100 place. In the first case, there will be at least 1, 3. That means each of the number may have 1 or more than 1 3's. First case, 3 at the unit place. Three at the units place. Follow this diagram. 3 is there. Then this place, hundreds place, will be occupied by any of the any of the 9 digits starting from 1 up to 9, except 3, and 0 cannot be placed here because in that case that will be 2-digit numbers. Therefore, I mark this not equal to 0, 3. That means this place can be filled in 81 ways. Total number of digits Total number of digits is 10. Since 0 cannot be placed here, therefore this digit cannot be 0. Sorry, 3 may be occupied. Therefore, now this tens place can be occupied by 0, 1, 2. That means 10p 1 ways, and this is filled in one way. 3 at the units place, therefore tens place can be filled in any of the digits 0, 1, 2, 9, and that can be done in 10p1 ways. Therefore, and hundreds place can be filled in 9 ways, as 0 cannot be placed out of 1, 2, 3, 9. Follow the reasoning. We are placing 3 at the units place. Since at least 1 3 will be there, therefore after putting 3 at the units place, tens place can be filled in 10 p1 ways out of the digits 0, 1, 2, 3 to 9, because any of the remaining digits of 0, 1, 2, 3 9 along with 3 can be placed here. Since at least 1 3 is there, already we have put 1 3. Therefore, in this case, we can put any of the digits starting from 0 to 9. Now, hundreds place. 0 cannot be placed here, because if we put 0, then the numbers, each of the numbers formed will be 2-digited. That means this can be filled in remaining 9 digits starting from 1 to 9. Therefore, total number of ways of forming 3-digit numbers where 3 is at units place is equal to product of these 9p1 into 10p1 into 1. Why 1? Because 3 is placed at the units place. That means we can say 3p1, 3 in one way rather. Therefore, that will be 90 ways. 3 is already placed, that means in one way. Now, we consider case B. I write this one. Case B. Three is placed in the tens place. Now let us discuss. There will be digits in the units place except 3. That means any of the 9 digits. Any one digit out of 9, 0, 1, 2, 4, 5, 6, 7, 8, 9. 100 place, this cannot be 0. Therefore, this place also can be filled except 0. That means out of 9 digits, in how many ways? Let me repeat. Since 3 is placed at the tens place, therefore units digit can be filled in how many ways? Except 3, that place is filled by other 9 digits. That can be done in 91 ways. And in case of hundreds place, that cannot be filled by the digit 0. Therefore, this place can be filled in by 91 ways. Therefore, total number of ways of forming three-digit numbers where 3 is placed in tens digit is equal to 9p1 into 9p1 into 3. 1. Because already we have put 3 in the tens place and is filled by 3. Therefore, units place is filled by any of the digits 0, 1, 2, 4, 5, 9. That is 9 digits, and that can be done in 9p1 ways. Now, hundredth place. Place can be filled in, except 0. 0 cannot be placed. Filled in 9p1 ways. Therefore, total number of ways of forming 3-digit numbers where 3 is placed in tens place is 9p1 into 9p1 into 1, that is 81 ways. Follow that. I have drawn diagrams here and written the statement here. Now case C. Three is placed in the 100 place. 3 is at 100's place. As we have already considered the cases of putting 3 at the units place and tens place earlier. Therefore, each of these two places can be filled in by any of the digits tens place and units place. Each of tens place and units place can be filled in 9p1 ways. As already we have considered, 3 is at the units place as well as tens place. Therefore, in this case, where 3 is at the hundreds place, cases of 3 in tens and units place is to be discarded. Therefore, total numbers in this case is equal to 9p1 into 9p1 into 1. 9p1 into 9p1 into 1. I write this matter here, that is equal to 81. Therefore, total number of 3-digit number where there is least 1 3, at least 1 3 is equal to, in the first case we got 90, in the second case we got 81, in the third case we got also 81, this is the answer of the part 1 question. How many numbers are there between 100 and 1000 such that at least one of their digits is 3? Here 3 may be used one time or two times or three times. Therefore, the first part is solved. Now, second case, exactly one of the digit is 3. Again, I draw like this. Units place 3. Tens place 3. Next, hundreds place 3. Case A, 3 is at tens place. Therefore, I mentioned since exactly 1 3 is there, therefore any of tens place and 100 place can be I first consider tens place. Tens place can be filled in by which digits? Not 3. Therefore, 9 out of 9 digits starting from 0, 1, 2, 4, 5, 9 can be filled in by 9p1 ways, and hundreds place can be filled in cannot be 0, 3, therefore filled in by 1, 2, 4, 5, that is by any of the 8 digits in 8p1 ways. Therefore, total numbers is equal to 9p1 into 8p1 into 172. Now we consider this is case A, case B. Here 3 occupies tens place. Case B, 3 occupies tens place. From the diagram it is clear, the hundreds place cannot be filled in by 0 or 3, since if we put 0 in the hundreds place, then we get 2-digit numbers, and exactly 1 3 is used, and units place cannot be 3, as exactly 1 3 is used. 3 occupies tens place, therefore number of numbers where 3 is at the tens place is equal to 8p1 into 1 into 9p1. Now, when 3 is at the hundreds place, I rub these two cases, or I write it case C. Three is placed at the hundreds place. Therefore, tens place cannot be 3. Also, units place cannot be 3. Hundreds place 3, since digit in the is 3. Therefore, any of the tens place and units place can be filled in by any of digits 0, 1, 2, 4, 5 to 9 in 9p1 ways. Therefore, total number of numbers in which 3 is at 100 place is equal to 1 into 9p1 into 9p1, 81 ways. Therefore, finally, I will consider answer. Total number of 3-digit numbers in which exactly 1, 3 is there is equal to 72 plus 72 plus 81. 72 plus 72 plus 81, result will be 225. Thus, I have discussed two cases when at least 3 will be there while we form 3-digit numbers, and second case is exactly 1, 3 will be there. Next sum, 5 men and 4 women sit in a row so that the women occupy even places. We have to find how many such arrangements are possible. First type, total number of persons sitting arrangements. I must give some space between two rounds. Five men are there, and women will occupy even places. As per condition, men will occupy odd places. That is first, third, fifth. I mark like this. I have encircled the positions of the main. When main occupy odd places, how many even places are there? 1, 2, 3, 4. In between two successive main. As per condition, main will occupy odd places, that is first, second, fifth, first, third, fifth, seventh. 4 women are there. Therefore, 4 women can sit in those places in 4 ways. That is factorial 4 ways. Five men can sit in odd places, that is first, third, four women can sit in those places. Four women can sit in 4 ways. Sorry, I have mentioned here wrongly. 4 women can sit in even places. Sorry. Even places. Second, fourth, sixth, eighth. In 4 ways. That is factorial 4 ways. 24 ways. While 5 men can sit in odd places, that is first, third, fifth, seventh, and ninth. In 5 ways, that is factorial 5 ways equal to 120 ways. Therefore, those 9 persons can sit totally in 4p4 into 5p5, that is 24 into 120, 24 into 120, result is 2880 ways, in which women will sit in even places. Now problem number 3. If there are 6 periods in each working day of a school, in how many ways can one arrange 5 subjects such that one subject is allowed at least one period? 6 periods are there, 5 subjects are there. Therefore, if we allowed one subject, then out of 6 periods, 5 subjects will be, since one subject is allotted in one period, therefore 5 subjects can be given in 6 periods in 6 P5 ways. That means if we consider like this, one left, the remaining one period can be given from 5 subjects in 5 P1 ways. Therefore, total number of arrangements of classes is equal to 6p5 into 5p1 ways. 6p5 into 5p1 ways. Now we calculate that factorial 6 by factorial 1 into factorial 5 by factorial 4. Six into 5 into 4 into 3 into 2 into 5. After calculation it will be 720 into 5. while we allot one subject for one period, therefore to allow 5 subjects, one for each period will be made by 65 ways. Since 6 periods are there, now already we have allotted or allowed 5 periods, then one period is left. That remaining period can be allowed by one subject in how many ways? Since we have 5 subjects, therefore 5 P1 ways. Therefore, total number of arrangements will be 6P5 into 5P1 ways. And after calculation, it is 3600 ways. Now I discuss few theories. First of all, n different things are there where to fill or where to take r things together and arrange. And the restriction is one particular thing will be there in each arrangement. Now, in how many ways we can do that? Now, one particular thing can be placed in r places. One particular thing can be placed in any of these r places in how many ways? R ways. One particular thing can be placed in any of r places out of n places in how many ways? R ways. Then how many places are not filled yet? R minus 1. Places can be filled by from remaining n minus 1 things in how many ways? N minus 1 in r minus 1 ways. Therefore, total number of ways of filling r things out of n different things in each of which a particular thing will be there is equal to r into n minus 1 p r minus 1. Follow this. One particular thing is to be taken in every arrangement, while we are taking r things out of n different things. Now that particular thing can occupy any of the r places in r ways, and remaining r minus 1 places can be filled in by remaining n minus 1 things in how many ways? N minus 1 p r minus 1 ways. Therefore, total number of ways will be r into n minus 1 p r minus 1 ways. Now, we are going to find the total number of arrangements of r things out of n different things. Already that is discussed, that is NPR. Now we are going to give the other form of that formula, that is NPR equal to NPR is equal to R into n minus 1 PR minus 1 plus n minus 1 PR. Now let me clarify that. Now the arrangement can be divided into two parts. One particular thing will be there, and one particular thing will not be there. One particular thing will be there always while we are taking r things at a time, and in the other part one particular thing will not be there. Now if we combine these two, we get the permutations of n things taking r things at a time. Now one particular thing will be there to fill r places. We consider like this. Now that particular thing can be placed in any of the r places in how many ways? R ways. Now the remaining places R minus 1, as already we have used the particular thing, that means number of things remain n minus 1. Therefore, out of those n minus 1 things, we have to take more r minus 1 things, and that can be made in n minus 1 p r minus 1 ways. One particular object will be there, that is in r into n minus 1 p r minus 1 ways. Now the other case is one particular thing will not be there. One particular thing will not be there. That means we have left n minus 1, n minus 1 thing. Out of this, this is the first case, this is the second case, plus r things out of therefore we can say total arrangements is NPR, that can be split into two. NPR equal to then R into n minus 1 p r minus 1 plus n minus 1 pr. This is very easy to understand after discussing the previous restricted permutations. Thus, different matters of arrangements or permutations have been discussed. In the next episode, I shall discuss few more sums on permutations. Now I am moving to combination.